Alright, so let's get to this square root 1. So I'm going to say some of the standard stuff I said several times already. This is an elementary function. It's composed of square roots and division and addition and subtraction. However, I'm in trouble if I plug in h equals 0. I can see that right away on the bottom, and also on the top I'm also getting 0. But yeah, the real problem is getting 0 on the bottom. So that tells me that I cannot just plug in h equals 0. What I have to do is some algebra. So let me just make a little note of that. So what type of algebra am I going to have to do? There's something special we can do for square root functions like this. I'm going to multiply by something on the top and the bottom. And the thing I'm going to multiply has a special name. It's called the conjugate. Here's what the conjugate means. Here I have like the difference between two numbers. It's like this number minus this number. The conjugate is just going to be this number plus this number. On the top and the bottom. Now, why would we do such a thing? So recall the following. A minus b times a plus b is a squared minus b squared. It's just the formula for the difference of two squares. And what I have here, like if I call this the square root is a and then 4 is b, then I have a minus b times a plus b. I can multiply that out, so it would give me a squared. So what is a squared? If this is a, then a squared just takes the square root off. So this is a squared. And then, well, b was 4, so b squared is 16. And on the bottom I have h, and I still have this on the bottom. And I'm not going to multiply out the bottom. I'm going to keep the bottom factored. And this is a strategic move that I'm making because I would like to cancel something from the bottom, and that's easier if I keep it factored. So on the bottom, I just write this times this. Like I'm not distributing the h. I could do h times this plus h times 4, but I'm not going to bother. Because look, here's what happens. I've got 16 minus 16, so that's gone. So now the only thing on the top is an h, and then I can cancel this h with this h. So actually, yeah, I'm tempted to just cross this off, but let me. What would be left on the top after I can't, because after canceling the 16, all I have is an h. And if I cancel that with this h, then the top is now just a 1. On the bottom, this is gone. And all I have is this. Okay, so then now, after doing this algebra, I can plug in 0 for h. And what's a good clue that I can do that? First of all, if I think about it, I can just plug it in. And clearly I don't get 0 on the bottom anymore. Why could I predict that that would happen? It's because we just canceled the h from the bottom. This h in the bottom was exactly what was making us divide by 0. I mean, we're doing h goes to 0, and h is right here in the bottom, so that, like, this h is putting a 0 in the denominator. So once that h is gone, I suspect that maybe my problems are gone. And indeed they are. So I can put in 0 for h. I've got this. So this is 4 plus 4 in the bottom, so I get 1/8. All right. Let me do one more like that. It's this one. I'm doing it, I wrote it like this because this is very similar to one from the online homework. Of course, I would prefer not to write it like that. This -1 power, I mean, I can deal with that, but I would really prefer to write it this way. When I do something to the -1 power, that's like 1 over that. So this is how I would prefer to write it. Of course, I have the same issue. I can't just plug in 0 for h, because on the top I would get a half minus a half, and on the bottom I would get 0. So let's do some algebra. In this one, there isn't any, I wouldn't say any special trick. I'm just going to do some stuff that just generally simplifies. So what bothers me is I don't like fractions inside of fractions. Like, this whole thing is a fraction, where the numerator is this, so the numerator has fractions in it. The denominator doesn't have fractions in it, but the numerator does, and that bothers me. I would like to have a much simpler fraction where the numerator doesn't have any fractions in it, and the denominator doesn't have any fractions in it. Like, the whole thing's a fraction, but it's not like there's fractions in the top and fractions in the bottom. So what I'm going to do is I'm going to multiply the top and bottom by something that kills all these denominators. So I see a 2 plus h in the denominator and also a 2 in the denominator. So I'm going to multiply by 2 plus h. And if I do that, I better also do that on the bottom. Okay. Now, we've done something similar to this before. What I have to do is I have to multiply this out, but I have to be a little careful. Different things are going to cancel in different places. I have to take this and I have to multiply that here and also here. So what happens when I take this and multiply that here? The 2 plus h is going to cancel with the 2 plus h, but this 2 is left over. So this 2, that represents this times this. I still have to do this times this. So let me write a minus, and this is from this minus, and now I'm doing this times this. And when I'm doing that, the 2 cancels, but the 2 plus h is left over. And I'm going to be careful and use parentheses here, because otherwise I might forget that this minus sign gets distributed. Yeah. On the bottom, my strategy is going to be similar to last time. I'm not going to multiply everything out. I'm going to keep it factored. 2h, 2 plus h. Well, I guess I rearranged it a little bit, but I wouldn't say I multiplied it all the way out. I kept it factored. Now I'm hoping to cancel the h in the bottom, because once again, this h in the bottom is like the main culprit that's causing me to divide by 0, which I don't like. So it looks like I'm in good shape, because this 2 cancels this 2, and luckily I remembered my parentheses, so I remember that this is a minus h, not a plus h. And sure enough, I can cancel my h, and let me write a 1 here, because I don't like it when I cancel everything. It looks like everything's crossed out. So what's left over on the top is just a 1, and on the bottom is 2 times 2 plus h. And well, so I just canceled the thing that was causing me to divide by 0, so now I suspect that I'll be fine. And I am. If I put in 0 for h now, I get -1 on the top and 2 times 2 on the bottom, -1/4. Okay, good. Then let's talk about a few more. So these may look similar, and well, maybe in the big scheme of things they are, but they are different. So let's talk about this one. And I'll say the standard thing. Obviously, this is an elementary function. It's a polynomial over another polynomial. However, right away, I can see that if I'm plugging in 5 for x, I'm getting 0 in the bottom. Now, we just did a bunch of examples where we're getting 0 in the bottom and in the top. This time, I'm getting 0 in the bottom, but not in the top. As x goes to 5, the top is 11. So what happens if I take 11, okay, let me start over. Keep in mind that x is not exactly 5, so I'm thinking of the top as close to 11, but not exactly 11. And I'm also thinking of the bottom as close to 0, but not exactly 0. What happens if I take a number that's close to 11 and I divide it by a number that's close to 0? Is it should give me a huge answer. In particular, like we said, the bottom is going to 0. The bottom is always positive, though, because it's squared. And keep in mind, this is not a left limit or a right limit, so x might be a little bit less than 5, or it might be a little bit bigger than 5. But because this is squared, it doesn't really matter whether x is smaller than 5 or bigger than 5. This is always going to be a positive number because it's squared. So if I take 11 and I divide it by a very small positive number, like 0.0001, what I'm going to get is a huge positive number. And you can try that in a calculator. Take 11 and divide it by like 0.0001. It's going to be a very large number. What we say about this is that the limit is infinity. If you take a positive number, like a strictly positive number like 11, and you divide it by a positive number that's approaching 0, the limit is infinity. So let's talk about part B. In this case, the top, if I try to plug in 3, the top is -7. And again, the bottom is 0. I made this the 4th power, but it doesn't matter too much. The point is that it's an even power, so if I'm plugging in 3 or a number that's close to 3, I'm getting a number that's close to 0, but it's always positive because it's to an even power. So the top is going to -7. Bottom is going to 0. Again, the bottom is always positive. So what happens if I take -7 and I divide it by a a small positive number like 0.0001, what you're going to get is a huge negative number. So we say this limit is negative infinity. Okay, so what about this one? And actually, maybe let me make this one just a little bit more interesting. It's x plus 1 over x minus 1. In this one, it's maybe a similar situation. The top's going to 2, the bottom's going to 0. So let me take note of that. Top is going to 2. The bottom is going to 0, but it's not to an even power. So if x is a little bit bigger than 1, then I'm going to get a small positive number. And if x is a little bit smaller than 1, then I'm going to get a small negative number. So I can't say that the bottom is always a positive close to 0 or a negative close to 0. It depends which side x is going from. And this is not a left limit or a right limit. So I would say this limit does not exist. However, for example, okay, so I've already answered the question, but I just want to point something out. If this were a one-sided limit, now I would say the top is going to 2 and the bottom is going to 0, but the bottom is always positive because x is always a little bit bigger than 1. So if I take 2 and I divide it by a positive number that's close to 0, I would get a limit of positive infinity. And similarly, if this was a limit from as x goes to 1 from the left, I should get negative infinity. The answer to the original question is that it doesn't exist. And another way of explaining that is that the limit from the right is positive infinity and the limit from the left is negative infinity, so they don't agree. But yeah, so the answer to that one is does not exist. Yeah, so there's also things like this for trig functions, like the limit as x goes to pi over 2 from the left of tan x. And for this, it helps if you just take a look at the graph of tan x. It looks a bit like this. It has vertical asymptotes. Of course, this is a periodic function, so if I wanted to draw this, the full graph, I would take a copy of this and draw like another one here, and then after that, and then there would be one over here as well. But the important part of the graph for us is here, because I'm approaching pi over 2 from the left. So yeah, this just looks like a vertical asymptote. As I approach pi over 2 from the left, it looks like I'm going up and up and up. So this would be positive infinity. If I were approaching pi over 2 from the right, I would say negative infinity, because I would be looking at this part of the graph. But I'm not. Yeah, so let me do one more. I think I can squeeze it in this video. So this is sort of, it's superficially similar to some things that we did. It's an elementary function. If I just try to plug in x equals 2, I am going to have a problem. I'm going to get 0 over 0. So this is, typically, and let me explain a little difference here. In these ones up here, I was getting 0 in the bottom, but I was not getting 0 in the top. If you're getting 0 in the bottom, but you're not getting 0 in the top, there's 3 possible answers. Either it's going to be infinity, or it's going to be negative infinity, or it's going to not exist. Those are the only 3 possibilities. If you're getting 0 in the bottom, but not in the top. And the way you handle that is you try to figure out whether this 0 in the bottom is always positive or always negative, or whether it could be either one. And that tells you all you need to know. If you're getting 0 in the bottom and in the top, what that means is you should factor and cancel. And that's like several examples that we did. So let's try that. It's easy to guess. One of my factors is going to be x minus 2. So this looks like x minus 2, x plus 5. And the bottom looks like x minus 2, x minus 2. So I cancel. But look, even though I canceled an x minus 2 from the bottom, I still have an x minus 2 in the bottom. And so I still can't plug in x equals 2. But now this turns into like one of these, because now I'm not getting 0 in the top. In the original, when I tried to plug it in, I was getting 0 in the top. But after canceling, it looks like I'm getting 7 in the top. So now I'm going to treat this just like I treated those, because now this is like I'm getting 0 in the bottom, but not in the top. So I proceed from there. The top is going to positive 7. The bottom is going to 0. And since this is a limit as x goes to 2 from the left, so x is like a little bit smaller than 2, so I would say that the bottom is a negative number. So what happens if I take positive 7 and I divide it by a negative number that's close to 0? I'm going to get a limit of negative infinity. Okay, so let me call that a video.